Computer systems are literally everywhere, from the smartphone sitting in your pocket to the massive server farms running our global infrastructure. But today, we're not just looking at what they do. We're going to completely demystify exactly how they do it. Welcome to the Explainer. Let's dive right in and dissect the anatomy of hardware, software, and the flow of digital data. Think about the machine you're using right this very second. How does it actually work? For a lot of us, it's kind of just a magic black box, right? You press a button and boom, things happen. Well, we are about to completely unpack that box together and build a really clear, structured mental model of what's going on beneath the screen. Okay, let's dive into this. Here is our roadmap for today's top-down dissection. First, we'll hit the hardware and software formula. Second, we'll take a tour inside the motherboard city. Third, we'll look at the software platform layer. And finally, bridging analog and digital. Starting with Section 1, the hardware and software formula, we absolutely have to start with the foundational basics before we get into the really complex components. Think of a computer system kind of like a physical book. Hardware represents the tangible parts of the system, the actual pages, the cover, the ink. It's the physical structure that's just sitting there, waiting to hold something meaningful. Software, on the other hand, consists of the invisible instructions and programs that actually process the data. If hardware is the paper and ink, software is the words written on those pages. Without it, the physical machine is totally blank. It has no story to tell. And this brilliantly illustrates a profoundly simple system formula. Hardware plus software equals functionality. You need both to make it work. Without instructions, you literally just have a pile of expensive parts. But without physical parts, those instructions have absolutely nowhere to live. Moving right along to Section 2, inside the motherboard city. Let's move out of the theory and step inside the physical machine. Now, before we zoom all the way into the internal hardware, we have to bridge the human user to the machine. External hardware splits cleanly into two categories: input devices, like your keyboard, that push our commands into the system, and output devices, like your monitor, that push the processed data back out to us. But here's the thing. You type a key or speak into a microphone, and that input is captured. But where does it actually go once it leaves your fingertips or your vocal cords? Welcome to the motherboard. Now, what's really interesting about this is you can think of it as a bustling city map. It is the central hub connecting every single internal component. Those tiny copper and aluminum circuits, they're basically data highways, rapidly routing traffic from one district of the city to another. Smack in the center of that city is the CPU, the Central Processing Unit. This is the absolute brain of the operation, interpreting and executing every single system command. But this brain operates using two very distinct hemispheres. First up, we have the control unit. Think of this as the ultimate traffic controller, managing the immense flow of data rushing in and out, making sure everything goes exactly where it needs to go. The second half is the ALU, or Arithmetic Logic Unit. This guy handles the heavy lifting, the math and the logical operations. So one half directs the traffic, while the other half crunches the numbers. All right, next up on our city tour is memory. And we really need to distinguish between RAM and ROM here. RAM, or random access memory, is a temporary, volatile workspace for right now. If the power cuts out, poof, that data's gone. ROM, or read-only memory, is permanent. It's non-volatile storage that holds the essential BIOS instructions required just to boot the system up in the first place. Now, if RAM is just temporary, your operating system and all your files need a long-term home. That's your storage, which these days is typically incredibly fast solid-state drives, or SSDs. Rounding out our hardware city, we have expansion cards. These give the city specialized workers. You might drop in a graphics card for image rendering, a sound card for audio, or a network interface card specifically for internet connectivity. Section 3, the software platform layer. We are now moving from the physical city into the invisible realm of software that brings it all to life. Let's see how this builds, because software isn't just one giant bucket. It is layered. At the very bottom, system software provides the foundational platform. This is your operating system and your device drivers. Sitting right on top of that is the application software. These are the specific tools you actually interact with, like Word or Excel. And the key takeaway here is you literally cannot run your application tools without that foundational system platform underneath supporting them. And that brings us to Section 4, bridging analog and digital. How did these rigid, complex digital machines actually interact with our messy physical world?
So, the absolutely crucial point here is this: computers do not see the world the way we do, not even close. The real world is analog. It's smooth, it's continuous. Think of sound waves or temperature changes. But a computer only speaks a rigid digital language of zeros and ones. So, for a computer to interact with us, a massive act of translation has to occur at the border.
Let's walk through exactly how that translation journey happens. It starts in the real world with a smooth analog input, let's say the sound of your voice. That input hits an analog to digital converter, or ADC, which literally chops that smooth wave into rigid digital steps. Now, the CPU can process that data as pure zeros and ones. Once the processing is done, the data hits a digital to analog converter, the DAC, which smooths those blocky zeros and ones back out so they can be pushed through a speaker for human ears to actually experience. Putting the whole shebang together, we can see that nothing in a computer system works in isolation. It starts at the top with your user intent in the application software. The system software translates that intent into hardware instructions. Those instructions flow down to the CPU engine using RAM and storage to process the task, before pushing the digital result back across the bridge into the analog world. It is a continuous, flawless loop. Which brings us to the end of our anatomical tour, but it leaves us with a seriously fascinating question to ponder. Since everything in our physical world must be rigidly translated into zeros and ones for a machine to understand it, and things like audio, video, and text have already been mastered, what complex real-world analog inputs are going to be digitized next? Keep that in mind the next time you boot up. Thanks for joining me on this explainer, and stay curious.